Yeah.
10 class. Yeah, so it's simple as that. Just don't make it just don't think too much about it. Just relax and chill and just read the question carefully, what they are saying, understand it, and solve it. That's it. And stats one from week 1 to 4, I don't think so. It's a very difficult topic because we have already learned all about it, the mean, the median, the mode, and the
Yes.
correlation, variance. They are just a simple topics, correct?
Yeah.
Yes, ma'am.
Yeah. So it's not a big thing. Yeah. Main thing when it's come is in week not 5 6 5 6 7 8 from 9 to 12 it will be little difficult, like it will be little difficult, not that difficult, but yeah, it will be a new topic for you to understand till week 6 7 8. Till week 8 it will be fine, like you know everything, but from 9 to
Ma'am,
12 it
till
will be like a
that
new topic.
Actually,
conditional probability, right?
actually, the
Aha,
more we forward, the more I forget the earlier things. So that is the main things that I'm facing
what
actually.
you can do is, see, what you can do is you can just go through the, see, we have this revision session and all na. So when we have this revision session, so what the instructor, I don't know about the other instructor, but what I do is I just go through all the formulas, or I just go through all the topics that there are there in the week, in week 3 and week 4. Okay, then what I'll do, I have some 4 5 6 questions from the previous year and we will solve that. So that is what I'm going to do in this revision session. So in this week 3, like what I'm going to write, I will write all the things that are there, like a quick summary of week 3. And I will also give a quick summary for week 4. So from that, you can just see the formulas and the concept. That's it. So I guess that will be easy for you to brush up all the things, right?
Yeah.
Or what you can do is you can just make notes, like simple notes. See, from week 1 to 4, it's simple. From week 1, you don't have to make any notes. Like it's a literally like what do you say that what do you call that? Concept wise, or you can say only theoretical type, right? But from week 2 to 4, it's like little formula based, but the formula is basically that you have already learned. From 5 and 6, it's permutation and combination that you have already done in 10th class or 11th and 12th class, right? From 5 6 and 7 8, the probability, and also these type of things you have already learned, so you don't have to, like, like if you want to write it, you can have notes and all. If you don't, like, it's just a simple topics. Okay.
So like I feel that it would have been better if there was one exam per day. So
Sorry.
like it would be like it would really better. It would be better if the exam has been scheduled for a per one day and each subject. So
Oh, okay. Yeah, that's what. Yeah, I know that, but what can we do? We can't do anything about it. Yeah. So okay, that's fine. So that's why we are having MCQ and MSQ based questions now. Uh, like if you really go to the any university or campus based, like offline thing now, if you take classes offline and all, we had our exams one day. We had 2 subjects in one day, and it was not at all MCQ or MSQ. It was all theory basis. So it was like 10 marks each questions. We have to write it. So it's better you have at least MCQ and MSQ based questions. That is good.
Ma'am,
kind of a competitive exam type like MCQ question.
Uh-huh.
So
But it's not, even the questions are not that difficult in the question paper. So it's I don't think so it's that difficult. I don't know about the other subjects, but yeah, I know about the stat subject. I can say that it's not that difficult. It's literally concept wise. I can say that.
am I audible, ma'am?
stats is far better than maths. Maths is
Yeah,
I think tricky.
yeah, it depends upon person to person.
Uh,
Am I audible, ma'am?
Yes, you are audible.
Ma'am, I think it is good that multiple subjects exam are conducted in one day. I mean, it is pretty much doable. As I'm a
Mm.
level student and I have completed maths one,
Mm.
so it is pretty much doable.
Yeah,
If
see, it depends upon, see, there are different kinds of people, right? So every people have a different kind of mindset and they have their own opinion. Correct. So it depends. So it's not that. So that's why we have to make sure that the question paper that we are making is that everybody is able to do it. Like
yes,
it should not be a burden or something. But we also have to make sure that it's the question paper also are like they are not that easy that everybody will be able to do it. We have to make some consistency, or you can say the like what we have taught and all that. We should also know that yeah, students know these topics. We also have
yes,
to make sure that correct.
yes, ma'am. If we revise every topic and attend every session, so I think it's pretty much doable.
Mm. Correct. Okay, so it's already 6:15. We talked a lot. Let's start with the session, shall we? Okay, I'll just go through the topics. Okay, for week 3 and week 4, and then I guess 6 questions I have. We will solve that questions and we will wind up with the session. Is that fine?
Yes,
Okay,
ma'am.
let's complete it.
Ma'am, please can
Yeah.
we could you practice previous year questions?
Yeah, the questions that we will do is from the previous year questions only. Like I have 6 questions. They are from the previous year only.
Okay, ma'am. Okay, ma'am. Thank you.
Yeah. Okay. So the first thing is week 3. What we are learning about in week 3? Anyone?
Association between categorical variables.
Uh,
Oh, sorry.
Between
it is,
numerical.
between. So we are actually describing the numerical variables.
So the histogram
Two
stem
types
leaf
of-
plot.
Yes.
So we are actually describing about the numerical things, right?
Hmm.
Numerical data. So the first
Mean
thing that comes,
and-
so the first thing that comes up is frequency table, correct?
Yes.
Okay. What is a frequency table? If we have, let's suppose if we have a discrete data, okay, if we have a discrete data, then frequency table, discrete data in the sense if I have like 1, 1, 2, 2, 3, something kind of like this. Okay. So discrete data is in such a way that we make that we have some values. It's a table. We have some values. Then we have some tally mark. Okay, tally mark, and then we have some frequency. Okay, so this is what a frequency table look like. So value in the sense, what are the distinct values? We have 1, we have 2, we have 3, right? Tally mark in the sense, like how many times 1 is coming, how many times 2 is coming, how many times 3 is coming. So like 1, 2, 1, 2, 1, 2, something kind of like this. And we will write the frequency here, which is like 2, 2, 2. Okay, so this is what a frequency table. Frequency table, we are just tallying out. We are just writing out how many times a number is occurring. That is what my frequency table is. Okay, so this is about the discrete data. So if I have a continuous data, what I will be writing? I will be writing in a continuous manner. We will be having intervals, right? Interval in the sense we have a class limit, we have same tally mark, and we have the frequency as well. Okay, so class interval and tally mark. So in the sense, let's suppose I have a data from like 30 to like it's going on till 100. So I will be having class intervals. That means my data from 30 to 40, 40 to 50, 50 to 60, and so on like this. Then I will be having some tally marks here. Okay, that the frequency is 30 to 40 in the sense the numbers that are there, which is 30, 31, 32 till 39. 40 will not be included in this. 40 will be included in the second limit. Correct? Similarly, in the 40 to 50, 40 will be included, but 50 will not be included. Similarly, in third interval, 50 will be included, but 60 will be excluded. Okay. Now, similarly, here we will be writing all the frequencies. Okay. So this is how we make a frequency table for a discrete and a continuous data. Is that clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Then we have one more thing, which is known as a stem leaf diagram. Do you guys remember this thing?
Yes, ma'am.
Yes,
Yes,
What
ma'am.
is stem leaf diagram? Stem leaf diagram is basically we are just writing, like, see what in the exam, what we have a data in this form, correct? Or they will write it in this form. But we have a figure, a diagram in which the data can be represented in a stem and leaf plot, in the sense that this is my stem and this is my leaf. Okay, so that means there are numbers like 7, 5. Okay, then we have 7, we have 8, 5, 8. So this actually is representing that the data that I'm having is 75, 85, and 88, right?
In the ascending.
Yeah. So we are representing a data with a diagram which is known as a stem and leaf diagram. So stem is basically my the leftmost number, and my leaf is basically my rightmost number. That's it. Okay.
Ma'am,
Is that clear?
stem is like all the numbers except the rightmost, right? Except the unit place digit.
Correct.
If we
So-
have 3 digit, then
3 digit is, let's suppose if I have 851, then my stem will be 85 and my leaf will be 1.
yes, ma'am. Yes.
Okay, we can have, so it depends upon the, like, how you're representing it. Some of them, what they do is the 8 will be my stem and 51 will be my leaf. So it depends upon, so you have to, you have to tell it, or you have to describe it, that how I am dividing a data, a number, into stem and leaf. So if you remember, if you see in the questions, they already tell you that 7 divided by 5 will represent that it's 75, or they will say, let you know that 85/1 will represent as 851. So they will be telling you how they are dividing the data into stem and leaf. Which part
Yes,
belongs
ma'am.
to
It's
stem and which part belongs to...
written.
Yeah, it will be written. Okay. Is this thing clear?
Yes, ma'am.
Okay. Then next come is the descriptive measures. What are the descriptive measures? We are the measures that can summarize a data set. That is known as the, so we have to summarize the data. We have to numerically summarize the data. So we have a lot of data, right? So in that we have to numerically summarize the data. How will we numerically summarize the data? So for that, descriptive measures. So one thing is, first descriptive measure is the measure of central tendency. Okay, what is the measure of central tendency? That the measure which tells me about the center of the data, correct?
Yes, ma'am.
Yes, in the measure of so in the measure of central tendency, the one thing that comes up is Mean, correct? The most important central tendency for a numerical data is my mean. Okay, what is mean? Mean is actually my average of a data set. And what is the formula of the average? It is summation of xi divided by n. Summation of xi, like what all data I have, I will add them and divide by number of data I have. Okay, that is my average. And if suppose if I have like a continuous data, then my summation will be what? Summation of xi into fi divided by summation of fi. This is the formula of a mean. Okay, and most important properties of mean is that the first property is that if I add a constant, okay, if I add a constant, then my new mean will be equal to the old mean plus the constant. Similarly, if I multiply a constant, then my the new mean will be equal to the old mean multiplied by that constant. Is that clear?
Yes, ma'am.
Yes or no?
And also it's sensitive to
Sorry.
Sensitive
that
to
it's sensitive
outliers.
to out.
Yeah, and the third property, yeah, it's sensitive to outliers. Yeah, this comes after we study about the median. Okay, after we study about the median, then only we will get to know that, yeah, it's like sensitive to outliers. Okay, then we have median. What is the median? Median is actually my middle value. Correct? The middle value of the data set. So there are two points that you have to remember. The first point is if my observation is odd. If my observation is odd, then the middle part will be equal to n plus 1 by 2. And the second thing is if it is even, then my middle part will be, the middle value or the median will be the average of n by 2th and n by 2th plus 1th value. Or you can say the observation. Correct? And this is least affected by the outliers.
Ma'am, it
Yes.
is completely not affected, right, by outliers.
Yeah, it is not that completely, but means we can say, see, to mean it is least affected by the outliers. We completely it can be affected by the outliers. Like
Ma'am,
sometimes
outliers
what we say
are
is that keep like if you have in general case, like practically what we have, if I have a lot of data, what we do is we actually remove the outliers sometimes. Okay, so we have a condition. So we usually say that it is, or yeah, we can say that it's a least affected or like it is all affected by the outliers. But normally we say that it is least affected by the outliers. Okay.
okay.
Then yeah, same thing only. This here also, if I add a constant, what will happen? My old median will be, new median will be old median plus C. Then if I multiply a constant, then the old median will be multiplied by the constant. Okay, so these are some properties. Now the third part is the mode. What is my mode?
Most
The
typical
highest
value.
frequency.
Which is having the highest frequency, you can say, in simple terms, which is having the highest frequency. Okay, so how many times it is occurring? So same it goes for this. If we add a constant, okay, then the old mode will be like added with a constant. Then if we multiply, same, the old mode will be multiplied by C. Fine? Till here it's fine? So this was all about the measure of central tendency. Okay, then the second things, somebody was saying something. Somebody was saying something? No? Okay, so we studied about the central tendency. That means we are talking about the central point of the data set. Okay, now if we are talking about the central point of the, we actually don't know about the whole data set, right? We can have like two different types of data. Like let's suppose I have 3, 3, 3, 3, something kind of like this, and I can have a data sets like 1, 2, 3, 4, and 5. So by the measure of central tendency, I'm just pointing out a number, right? But with that one number, I'm not able to study about the data. Okay, so that's why we have another measure of a descriptive measure, which is known as a measure of dispersion. So what is a measure of dispersion? Measure of dispersion is actually indicating about the amount of variation of the spread in a data set. Correct?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Yeah. So in this measure of dispersion, we have few things. So the first thing is we have a range. What is a range? Range is the difference
the
between
maximum and minimum.
Max
the
minus
largest
mean.
minus the smallest value, you can say. Okay, that is my range, or you can say the maximum minus the minimum value. Okay, now this range is actually sensitive to,
Okay.
it is actually sensitive to outliers. Okay, then the second part comes as variance. What do you mean by variance? Variance actually tell me the variability of the data set. How my data value, let's suppose if how my data value like is away from the mean. So I am actually calculating the distance of the data from their mean. So I am actually calculating the variability of the data set. Okay, so this is my variance. And what is the formula of variance? Variance is denoted by sigma square, which is summation of xi minus x bar whole square divided by n. So now here there are two things. If I'm talking about the population one, I will be dividing it by n. Or if I'm talking about sample, I will be dividing it by n minus 1. Yes or no?
Yes, ma'am.
Okay, so yeah, so these are my two formulas here. Now in this case also, if I add,
Thing
it
change.
won't be affected. So my old it will be equal to my old variance.
Then it will
C
be changed.
square. C
It
square
will be c
into
square into
Old
the
variance
variance.
into C square.
Correct, correct. Now there is another term which is known as the standard deviation. What is standard deviation?
root
The
under
root
of
of the variance.
Variance. Okay. So here also we have, it is denoted by sigma, which is under root of summation of xi minus x bar whole square divided by n or n minus 1. Okay. Similarly here, if I add constant, if I add a constant,
no change.
no change, it will be equal to my old standard deviation only. And if I multiply a constant,
C into
So,
old
Old variance
SP.
into C.
mod of c into
Hmm.
old
Old
standard.
standard deviation.
Correct? So that is my measure of dispersion. Then next topic
Ma'am, is it
comes
mod
as
of C? Multiplying minus negative number, then the new standard deviation will be the
yeah.
mod of
So see, if you see here, na, see, if I multiply, so if you look into here, this is c square into old variance, correct?
yes, ma'am.
If I have to calculate the standard deviation of this new one, the standard deviation of c square into the old variance will be equal to what? Square root of this whole thing.
Yes, ma'am.
So c square,
Yes,
this so this will be what? C
Positive one.
into the old standard
Into
deviation.
old
So c
standard.
square, this will be positive only, right?
Hmm.
That's fine. Okay.
Okay.
Now we have the next topic, which is percentile. What is a percentile? Anyone?
So suppose we have NP percentile, then NP percentage of the data are
The thing
below
is,
me,
we are just dividing the whole thing into 100 percentile. Like there are 99 percentiles here. Till 99. So we are dividing a data into 99 parts. Okay. So each of the part is just telling me 1%, 1%, and 1%. Okay. So in this, what we say is we have like, let's suppose I'm saying 25th percentile. Okay. What do you mean by 25th percentile? That means 25% of the people are under me and 75% of the people are above me. So I'm at the 25th position. Is that then clear?
Yes.
yes,
Okay. And 50th percentile, what is the 50th percentile? It is actually denoting the
median.
median. Okay. And what do you mean by 75th percentile? It is actually telling me that 25% of the people are above me and 75% of the people are below me. Correct?
Yes, ma'am.
Okay. Now, what's the procedure to calculate a percentile?
It will be 2. If NP
The first procedure is we will
like if we arrange
First we
arrange
calculate in
the data.
yes,
arrange in the ascending.
in ascending.
Everything good?
Yes, ma'am. In detail, they are explaining.
Okay, then that's good. That's perfect. Okay.
Ma'am, shall we get any bonus mark from graded assignments?
No bonus mark is just that like there will be one exact question that will be coming from the graded.